Okay, on the basis of what I just explained, we can write the general formula of diazonium salt as Rn2 plus X minus or Arn2 plus X minus. To give an example for this, you can have a benzene ring N2 plus. Instead of X, you can have a chloride atom. And in this case, let me give you this example which I just explained for naming C2H5 N2 plus Cl minus. But when you compare the stability of these two compounds, this is more stable due to resonance. This R group, that is ethane, cannot undergo resonance. Therefore, unstable. And the condition for this being stable is it should be at low temperature. So at low temperature, they are quite stable, because of which we are going to deal mainly with the diazonium salts containing benzene ring. So if I draw the resonating structure for this compound, N triple bond N, this N carries a positive charge. Now what happens is this will shift over here in the form of negative charge, and this will come and form a double bond over here. So the first resonating structure will be double bond N with a negative charge. Since this carbon is losing its electron, this will have a positive double bond and double bond. Now what happens is, again, delocalization takes place. So this will come and try to stabilize this positive charge, and instead this carbon will have a positive charge in the next structure. So this will carry a positive charge now, and double bond N with a negative charge, and this double bond. Now what happens is, again, this will come and stabilize this positive charge, and this will carry a positive charge in the next structure. Double bond positive, double bond N with a negative charge. Now in the next case, this will come over here to stabilize this positive charge, and N will carry a positive charge, and this will come back and sit in the form of double bond. In this case triple bond, and your structure will be N triple bond N, and this N will carry a positive charge. So these are the resonating structure, because of which arene diazonium salts are stable in nature compared to the aliphatic diazonium salt. 1, 2, 3, 4, 5 contributing resonating structures, because of which they are more stable compared to the aliphatic diazonium salt, where this alkyl group cannot undergo resonance like this. So this is about the stability of the arene diazonium salt compared to the aliphatic diazonium salt. Now next one is their physical properties. Okay, under physical properties, they are colorless, solid crystalline, they are soluble in water, and they are stable in cold water, but reacts when it is warmed. So again, you need to remember the low temperature for its stability. Colorless, solid, crystalline, which is soluble in water, stable only at low temperature. As you increase the temperature, it also starts reacting. So that's about physical properties. Okay, now coming to the chemical properties. of diazonium salts, which is important. Now, chemical properties can be of two types. The one which involves replacement of N2 molecule, replacement of N2, and there's another type of chemical reaction where you're going to retain the N2 in the product. Retention of N2. The reactions involving replacement of N2, and the other one is reaction involving retention of N2. Okay, let's first start with chemical reaction. Chemical reactions involving replacement of N2. Okay, the first one is replacement by halide. Okay, I'm going to take the example of a benzene diazonium chloride in this case, N2 plus Cl minus. When you react this with cuprous chloride, Cu2Cl2 in the presence of HCl, or when you react this with cuprous bromide, Cu2Br2 in the presence of HBr, you will get the corresponding halogen instead of this group. So if I treat it with cuprous chloride and HCl, you are going to introduce a chlorine atom here and N2 gas will be released. Whereas in this case, when you treat it with cuprous bromide in the presence of HBr, you are going to introduce a bromine atom on the benzene ring, Br plus N2. So this type of reaction where you are using a Cu2Cl2 in the presence of HCl and Cu2Br2 in the presence of HBr is called as Saint-Meill's reaction. The same thing can be done but in a different way. That reaction is called as Gattermann reaction. For example, this can be halogenated N2Cl by treating it with copper powder in the presence of HCl and by treating copper powder in the presence of HBr. So when you treat it with copper powder in the presence of halogen acid, that is HCl, you are going to introduce Cl atom on this, and if you are introducing HBr in the presence of Cu, you will get benzene with Br. In both the case, N2 gas is evolved and plus Cu Br plus Cu Cl. Now this type of reaction where you are using copper powder is called as Gattermann reaction. Now it was seen that Saint-Meill's reaction yields better compared to Gattermann reaction. In both the cases, Cl is being introduced and Br is also being introduced. In this case also Cl is being introduced, Br is being introduced. But the only thing is, in the Gattermann reaction you are taking copper in the presence of HCl, whereas in this case you are taking cuprous chloride in the presence of HCl and cuprous bromide in the presence of HBr. So this makes the difference between Gattermann reaction and the Saint-Meill's reaction. And if you compare the yield of Gattermann reaction and Saint-Meill's reaction, Saint-Meill's yields better compared to Gattermann reaction. Next one will be replacement by iodide. So to replace it with iodide, let's take again benzene diazonium chloride, and when you treat it with potassium iodide, you will get iodide plus KCl plus nitrogen gases evolved, For introduction of iodide, you are going to treat it with potassium iodide, and this nitrogen gas is evolved. This Cl will react with this K and forms potassium chloride, and instead of this group, this I comes and sits. So this is about replacement by iodide. Okay, then the next one is replacement of N2 by fluoride ion. In this case, we are going to treat benzene disonium chloride N2 plus Cl minus when it is treated with fluoroboric acid, that is HBF4. It is fluoroboric acid. What happens is you are going to remove HCl from here, and this will form N2 plus BF4 minus. Now this on heating you will get fluorobenzene and N2 gas is evolved plus BF3 is formed as a byproduct. This is how you have introduced fluorine in the place of this group. When you treat it with fluoroboric acid, what happens is hydrogen and chlorine from this molecule will combine, and you are going to remove an HCl, and this NBF4 gets connected to this nitrogen atom. Now when you heat this compound, you will get fluorine in the place of this. So one fluorine will come and sit over here, fluorobenzene will be formed, N2 will be released, and what is left is BF3. So this is how you have introduced fluoride. Now from this intermediate, from this you can also introduce nitro group by treating it with sodium nitrite, NaNO2, in the presence of copper, and you're going to heat it. You will get you're going to introduce a nitro group. It releases N2 gas plus it forms NaBF4. From this you can introduce fluorine atom. From this you can introduce nitro group by treating it with sodium nitrite in the presence of copper and heating it. So in this way you have introduced this group with two different groups. That in the first case it is fluorine, in the second case it is nitro compound. Okay, this is about the replacement by fluoride, and you can also add nitro group, replacement by fluoride and nitro group. Replacement by OH ion. Now for this you are going to treat benzene disonium chloride with water. It consists of OH minus and H plus. Now what happens is OH gets introduced on this, plus nitrogen gas is evolved, and plus HCl is formed as the product, byproduct. So this is your phenol. Disonium salt, when treated with water, you will get phenol. Okay, then the next one is replacement by hydrogen atom. You have your disonium chloride, benzene disonium chloride. When it reacts with a reducing agent H3PO2 in the presence of water, you are going to get a benzene ring, because this entire group will be replaced by hydrogen atom donated by this hypophosphorus acid. Now this acts as a reducing agent which donates hydrogen atom. This donates hydrogen atom which replaces this N2Cl group over here. So you don't have to write hydrogen atom over here because it is understood that hydrogen atom is present. Plus, and then this reducing agent gets oxidized to phosphorus acid H3PO3 plus nitrogen gas is evolved plus HCl. So this is the product being formed. N2Cl is replaced by the reducing agent hypophosphorus acid which donates hydrogen atom, and itself gets oxidized to phosphorus acid. Phosphorus acid. Okay, now instead of hypophosphorus acid, you can also use alcohol as the reducing agent. N2 plus Cl minus plus CH3 COH, CH3 CH2OH, ethanol can also be used as the reducing agent. So alcohol, when it is acting as a reducing agent, it gets oxidized. So what happens is you will get, again, this group will be replaced by a hydrogen atom from this. So you don't have to show the hydrogen again. Plus, this gets oxidized to aldehyde. So this will form CH3, C double bond OH, ethanol. Plus, again, nitrogen gas is evolved plus HCl. In the first case, I have used hypophosphorus as the reducing agent, and in the second case I have used ethanol as the reducing agent. The reducing agent gets oxidized. So this is about replacement by hydrogen atom. Okay, so we just finished reactions involving replacement of N2 group. Now the next type of chemical reactions is reactions involving retention of N2 group. Now this type of reaction is also called as coupling reaction. So the compounds formed in this reaction are used as dyes. Now let me take an example for this. I have my benzene diazonium chloride, N2 plus Cl minus. When it reacts with phenol, and this reaction takes place in the presence of basic medium. Now what happens is the fourth carbon atom, first, second, third and fourth carbon atom gets connected to this benzene ring through the azo group, coming together. So in this case, the product formed will be N double bond N, benzene ring, and this OH plus Cl minus plus H2O is produced as the byproduct. Now if you name this compound, this is para-hydroxy-azobenzene. Para-hydroxy-azobenzene, and this is orange in color and used as orange dye. So this is when benzene diazonium chloride reacts with phenol, the fourth carbon atom, and this benzene ring connects through this azo group. Cl minus is evolved and H2O is formed as the byproduct, and the main product formed will be para-hydroxy-azobenzene, which is orange in color. Now the next one is I can take benzene diazonium chloride with aniline instead of phenol. So I'm going to do this reaction with aniline. Okay. NH2. And this takes place in acetic medium. Now what happens is, again, connect this with this through this azo group, and you will get N double bond N, benzene ring, and your amine group NH2 plus Cl minus plus H2O. Now the name of this product is para-amino-azobenzene. Para-amino-azobenzene. Now this is used as yellow dye. So you can say that the products formed from coupling reactions are compounds which are used as dyes. So with this we are done with the reactions involving retention of N2 group, and also we have come to the conclusion of this chapter. Okay, so with this we are done with this chapter. The first thing we spoke about was the chemical properties and the diazonium salts. Ta thari zina da lanzo khari chere na nar ba thangbonya la lanzo carbon test ni go su ba chemical properties lama dine. Carbon test the primary amines chupuche primary aliphatic na primary aromatic itageres. Then reaction with nitrous acid. Reaction with nitrous acid the primary ki logot tungire, secondary ki logot tungire, tertiary ki logot tungire. Then reaction with aryl sulfonyl chloride. Primary the secondary chupu ki react chigres. Aryl sulfonyl chloride nimdo. Tertiary the react chigru elana chigi maris. The carbon test reaction with nitrous acid ani reaction with aryl sulfonyl chloride lejuba. Then so sum the kharila pije chugolana primary, secondary, tertiary means eva chiala ani then so sum pije chigres. Then also electrophilic substitution goes over. Electrophilic substitution kharichine to gorana aniline ki namo la NH2 ka lone pair the electron the mar benzene the resonance to give this sambala negative charge the call delocalized na ortho the para la delocalized chaiwa. This in NH2 you became ki electrophile chilo nilego the carbon yana niva la dure yana hare carbon shiva la dure sani. This check. Then also electrophilic substitution thambo the bromination chirwa. Kisi bromination chidu sabala NH2 group the project machi goreshna ani also tri substituted compound transless. The tri substituted moe che also mono substituted goina ani NH2 the product che also acetylation chirwa in the presence of pyridine. Chiba chiga nitration like ani thambo yala NH2 group the product chi ani also correct mono substituted para product iralwa. दूसरे कैसे नाइट्रेशन का सो प्रोडक्ट मच्छी बरचना अनि ngazula mixture की compound mixture चिरा रहे तांबो दी para compound निवा दी second ortho compound अनि सुबह दी meta उन्हीं चना meta form चाहिए मारवा NH2 दी activating group इधर संभाला इन्हें NH2 दी H plus नियम तो react चाहिए इधर संभाल कोई anilinium ची form चाहिए वारस दी anilinium ion NH3 plus दी deactivating इधर संभाला अनि ngazula meta product ये वारस दूसरे and then also sulfonation chile by treating with concentrated sulfuric acid. Those chine chemical properties and then also topic saw khari na diazonium salt. Yeah, diazonium salt nalo lage ko ming cheda khanje me and korangi preparation khanje me and then chemical properties che. And ming cheda la thambo di hydrocarbon part che benzene na benzene then ni N2 diazonium ladiche and then anion giving the benzene diazonium chloride the anion in this sambala chloride mean the last negative part to say suffix chai rakho ta mean jaisa vejulan ko physical properties khari lena so solid crystalline or soluble in water and condition khari lena so stable in the air la condition the temperature low ho rahe is the temperature the amount of and stability the me achai is then also chemical properties go so that diazonium salts ke chemical properties ke naam la ko the chemical reaction ni tungire thambo the retention of N2 group niwa dela replacement of N2 group that thambo also replacement of N2 chiwa de ki naam la replacement by fluoride, replacement by chloride, replacement by iodide, replacement by hydrogen, replacement by OH, replacement by NO2 to jo chire. And these are retention of N2 in our reaction chick that is coupling reaction. Coupling reaction karichin lavolana aromatic compound ni manyam to two obodes. Two ni disurelana for an intimal N2D. And coupling reaction now la chick the diazonium salt in barba. And reaction each diazonium salt the phenol, diazonium salt the aniline. And then so ye catch a career and also dice sweat in the lapentoras. Karichinana product form chago D. Sunto you go to check. Kisi nyegi diazonium salt the phenol kina orange dye and kisi nye any diazonium salt the aniline ki varachna yellow dye form chayes dus and then diazonium salt ki phecho khari relana ta tanda chigo sama phecho rojbra diazonium salt yoga china ngala ko group organic group khari so hoina and deeper we introduce share lela kisi nga fluoride lo hoina fluorinating agent the phecho chloride lo hoina chlorinating agent the phecho diazonium salt acts as a good intermediate. So this So with this we are done with the amines chapter. In the next class I will solve some questions from the in-text and NCERT. So please read textbook, solve those questions as well. Thank you.